What is a vacuum? Let's find out once and for all. Webster's emptiness of space, a space absolutely devoid of matter, a space partially exhausted as to the highest degree possible by artificial means such as an air pump, a degree of rarefaction below atmospheric pressure, a state or condition resembling a vacuum, void. Void of what? Space entirely devoid of matter. An enclosed space from which matter, especially air, there we go, air, has been partially removed so that the matter or gas remaining in the space exerts less pressure than the atmosphere, air, opposed to plenum. Now, what in the world is plenum? Plenum, let's see, first time I've seen this word. Well, it says a space or all space, every part of which is full of matter, an air-filled space in the structure. All right, what else? As we look at this definition, a space usually above a ceiling or below a floor that can serve as a receiving chamber for air, okay, so still not a vacuum, but air, that has been heated or cooled to be distributed to inhabited areas. Almost like a ducting system, right? The whole of space regarded as being filled with matter, opposed to a vacuum. Well, it's not a vacuum, that's for sure. But according to Dr. Daniel Faulkner, the sky vacuum expert, he says pick any two spots in the air with one directly above the other, and you will have an example of a vacuum. Lower pressure coexisting with higher pressure with no barrier between or a container holding one back from the other. Now just remember this, because we'll be visiting this quite often. Vacuum, low pressure, and container. What about outer space? What is outer space? We've seen enough movies, haven't we? Well, according to Collins Dictionary, it's the area outside the Earth's atmosphere where the other planets and stars are situated, right? This is what they keep telling us. So no air in space, basically. This is where the vacuum's supposed to be. And the next one is going to come from Webster's, and it's going to say pretty much the same thing. Outer space. This is why they have astronaut suits and so forth, right? Space immediately outside the Earth's atmosphere. Okay, interplanetary or interstellar space. This is what it looks like. The Earth, the atmosphere, and the vacuum of space with no barrier. Well, where's the pressure coming from? Where'd you get the gas pressure in the first place, right? I mean, that's our question. Well, when you look at atmospheric pressure at sea level, it's 14.7 psi, 760 torr. And as you go up high, you could see that outer space is 10 to the minus 17 torr. Now, how in the world can you have gas pressure on Earth and outer space without any kind of barrier in between? We're going to visit that in a minute here. So you know this one, gas pressure next to a vacuum. Is it even possible? Well, here you got gas particles, and here you got outer space, a vacuum, 10 to the minus 17 torr, and somehow we have pressure of gas, but it's not hitting anything, which kind of doesn't make sense. So here we go, NOAA, air pressure. Let's find out how it works. The atoms and molecules that make up the various layers in the atmosphere are constantly moving in random directions. Remember that despite their tiny size, when they strike a surface, they exert a force on that surface in what we observe as pressure. They're hitting something. Each molecule is too small to feel and only exerts a tiny bit of force. However, when we sum the total forces from a large number of molecules that strike the surface each moment, then the total observed pressure can be considerable. Air pressure can be increased or decreased one of two ways. First, simply adding molecules to any particular container, there we go, will increase the pressure. A large number of molecules in any particular container, again, will increase the number of collisions with the, here we go, container's boundary, which is observed as an increase in pressure. So you need a container according to NOAA. A good example of this is adding or subtracting air in an automobile tire. By adding air, the number of molecules increase as well as the total number of the collisions with the tires in their boundary, a container, I might say. The increased number of collisions forces the tire's pressure to increase and expand in size. The second way of increasing or decreasing is by addition or subtraction of heat. Adding heat to any particular container, here we go, container again, can transfer energy to air molecules. The molecules therefore move with increased velocity, striking, how redundant, the container's boundary with greater force, and it's observed as an increase in pressure. Since molecules move in all directions, remember that? Molecules move in all directions. They can exert air pressure in all directions, folks. Whew. Okay, change in volume, change in temperature, add or remove gas molecules. This is what makes up gas pressure. So you can have a big tire, that's the change of volume, change the temperature, add more air. There it is, the three parts to gas pressure. But Danny Faulkner says pick any two spots in the air with one directly above the other, and you will have an example of a vacuum. Now notice what he says, two spots in the air. If I pick two spots in the air, don't I still have air? But he says there's a vacuum there. And he calls lower pressure a vacuum, coexisting with a higher pressure, with no barrier between or a container holding one back from the other. So far in our definitions, have we read that at all? I don't think so. Let's look at an airplane, how it works. You got high pressure underneath the wing, low pressure above the wing, and this is how you get lift. But notice, it's still in air. You still need gas pressure to fly an airplane. There's no way this is going to happen in outer space in a vacuum. What is the high and low pressure areas of an airplane wing? The wing of a plane typically has a curved top and a flat bottom. The airstream hitting the wing goes straight under the flat part, but has to also go up above the high part. Then it meets again at the rear of the wing. Notice that it meets again at the rear of the wing. According to Faulkner, it's a vacuum that meets back there somehow. Nonsense. The curved upper area causes low pressure by forcing air molecules to go faster across the top to reach the rear at the same time. A faster air velocity generally creates less downward pressure. The higher pressure, are you reading this, folks? There's no talk of vacuum here, just a differential because of the wing, which is the barrier that causes it. You can see it, it's the Bernoulli effect, it's seen in this diagram here. It's a pressure differential that causes the plane to have lift, not a vacuum. And here's another image that kind of says it exactly. Pressure of the slower moving air on the bottom and the pressure exerted by the faster moving air on top. No, it's air, not vacuum. And one last one here. So you got the thrust of the engine. I mean, what do you need a propeller for? If you're in a vacuum, do you need a propeller? Does this make sense? Well, according to Dr. Danny Faulkner, the vacuum expert. One more time, we must pick any two spots in the air, notice in the air again, with one directly above the other, and you will have an example of a vacuum. Lower pressure. That's double speak, folks. Lower pressure is not a vacuum, and the vacuum is not lower pressure. This is not true whatsoever. I'll demonstrate it. I was out on property. I saw this bird flying, which gave me the idea to film it and show you how beautiful the Bernoulli effect works with this bird's wings. Is this bird flying in a vacuum? Notice the trees moving with the air. According to Danny Faulkner, there's a vacuum above that wing. You buy that? You think there's a vacuum above that wing? You think with the degree and the PhD you could say lower pressure is a vacuum when I just read you the definitions of what outer space is, what plenum is, what a vacuum is, and how you can't have gas pressure without containment? You possibly think that this bird has a vacuum above his wings? Or is it just lower pressure? I know you know the truth.